Hey, this is Mr. Morrison, and today we're going to talk about slope. And here's a picture of lovely Hunter Mountain in upstate New York. And for those of you who have never been skiing or snowboarding before, here is a picture of where you have to start out, the Bunny Hill. And then hopefully, if you get a little bit better, you'll graduate to the blue trails on the ski slope. They're a little bit harder, more challenging, even better. You end up on a hill like this, and you get way better, end up on one of these. And the difference between these different ski slopes is just that they're slope, and slope is really a mathematical term to describe how steep something is. So you start off nice and flat, and then as you get better, it gets steeper, the slope increases. You get better, it gets steeper, the slope increases, and until it gets to be like that. Slope is also seen around your house in your steps. As you can see, these steps right here are just a little bit steep, and then steps up to the deck get way steeper. And in mathematical terms, it's a lot like correlations. There can be positive slopes, just like there's positive correlations, and they actually look just like positive correlations. When we did those, if you remember, the positive slope or the positive correlation looks something like this. So what this is saying is, as one value increases, as you go up positive on the coordinate grid, you're going up and right, which is also positive to get to the next point, up and right, up and right. Or if you want to think about going down the hill, you would go down or left, which is negative, and down, which is negative, left, negative, down, negative. So a positive slope, it has coordinates are the same. It's either positive or negative, just depending if you're going up or down the hill. Negative slope would be the exact opposite of that, just like negative correlation. Negative slope is going to look something like this. In negative slope, it's the opposite of positive, where the two signs are different. So if you were looking at this line, you go right, which is positive, but then down, which is negative. Right, which is positive, down, which is negative. Right, which is positive, down, which is negative. Or you go up, which is positive, left, which is negative. So the two signs are different from each other. So positive slope, they are the same, positive, or negative. And here they're opposite, positive and negative. Then there is zero slope. And zero slope looks a lot like the bunny line. Zero slope is really just a flat line that goes across like this. So this isn't really going up, it's not going down, just zero. So a zero slope doesn't really have a slope. The numerator is zero. It's not really going up or down, it's just going left or right. And then undefined is kind of the opposite of that. Instead of going left or right, undefined just goes straight up and down. And this, the denominator is zero. So this be undefined. You couldn't really go skiing down something that's just straight completely down. You could sort of go skiing on something like this, but this wouldn't be good. And slope mathematically can be described as, you might have even heard this in building terms, rise over run. Or another way of thinking about it is change in y. Remember, the y tells you left or right, which is the the y tells you up and down, which is the rise, how far up it goes over how far left or right it goes. So it's the rise, how far up and down you're going, over the run, how far left or right you're going. Just think, if you rise, you go up and down. If you run, you go left to right. So in this particular example, we have this line and want to find the slope of it. So you have point A, which I wrote down here, is -4, 2, and point B, which is 1, 2. So you want to figure out how steep this really is. So you have to see the rise, how far up you go, over the run, how far left or right you go. So you could just do this the old-fashioned way and count 1, 2, 3, 4. So it's 4, which is the rise, over 1, 2, 3, 4, 5. So it's 4 over 5. You're not always going to have this in front of you, so you also need to know how to deal with the coordinates. So it would be the x's are the runs, the y's are the rises. So you have to find the difference of these, how far you went up or down. So to find the difference, you would subtract. So you subtract the rises, so it'd be 2 minus -2, And hopefully you remember your same sign, add, and keep song, all that stuff. So 2 minus -2 will give you -4. And then you have to find the difference in the run. So it would be -4 minus 1, which is -5. So -4, -5, and since these are both the same, they're both negative, that would be a positive slope. You could also think of it as just a +4 over +5. These really mean the same thing because the two negatives would cancel each other out. One way -4, -5 just means that you're going down and over, and 4, 5 just means you're going up and over, up and over. It's just kind of going up the line or down the line, just depends on how you look at it. In this next example, just by looking at it, you can tell that it is a negative slope, and we would just go about this the same way. So we would look at the rise, which again is here, so we would do 4 minus 2, how far up or down it went, over the run, 1 minus 5. So 4 minus 2 will give you 2. 1 minus 5 will give you -4. You can simplify this if you would like to. 1 over -2, or the same upside down, -1 over 2. So this just means that you are going down 1, 2, down 1, 2, down 1, 2. Or if you went the other way, left 2, up 1, left 2, up 1. So either one of these would be the answer, or -0.5. So that would be the negative slope, and this would be the positive slope. Again, you can see how these are the same, so it's positive. These are different, so it's a negative slope. We're also going to get a little bit more into tomorrow when you're in class what it really means to be parallel and perpendicular. So now, instead of just looking parallel or perpendicular, you can actually prove it. Parallel lines, when you find their slope, have the same slope, and perpendicular slopes are perpendicular lines have slopes that are sort of opposite of each other, and we'll talk more about that tomorrow. If you could, please answer the questions on the Google form to the right. See you tomorrow.